Let's look at the solution of algebra bytes. If the roots of the equation 16kx square plus 8kx plus 1 are real and distinct, you have roots as real and distinct when the discriminant is greater than 0. The number of possible integer values that k can take between -2 and 3 both inclusive is. Okay, let's see. We will have discriminant as b square minus 4ac. So 64k square minus 64k has to be greater than 0, or k square has to be greater than k. K square has to be greater than k. We have also been given a range for which we have to check values of k. Let's just check. For k equal to -2, we get k square as 4. For k equal to -1, we get k square as 1. For 0, we get 0. For 1, we get 1. For 2, we get 4. And for 3, we get 9. We see that k square is not greater than k for 0 and 1. So these cases are cancelled. So the answer to the question, how many different integer values can k take between these? There are 4 such cases. Answer to the question will be 4. Next, how many ordered sets A, B, C, D exist such that A, B, C, D are integers, and we have this. A into B into C is equal to D, B into C into D is equal to A, so on and so forth. The fun thing that you can see here is, first is multiply all the LHSs, all the terms that are on the LHS. We will get A cube, B cube, C cube, D cube is equal to A, B, C, D. This we will get. Additionally, take A, B, C, D to the other side. You will get A, B, C, D taken out common. A, B, C, D whole square minus 1 should be equal to 0. A, B, C, D whole square minus 1 should be equal to 0. Okay. So now either A, B, C, D itself is equal to 0. And when you say A, B, C, D is equal to 0, given that all of them uniformly come on the right hand side, all of them uniformly come on RHS, one possible case for A, B, C, D would be when all of them are 0. This is an acceptable case. Another case would be when this part is 0, or A, B, C, D is equal to 1. When A, B, C, D is equal to 1. So one case when all of them are equal to 1, that would be acceptable. Another case when all 4 of them are -1, because then the product would turn to, when all of them are equal to -1, even that would be acceptable. In fact, not just these, we have 3 cases so far. Can you see, can you have some of them being -1? Some of them being -1, let's say 3 of them were -1. Let's say A, B, C was -1 and D was 1. Then while this bottom expression will turn to 0, but let me go ahead and see if that is valid. Can you see it would be a violation here? A into B into C will not be equal to D. So this is not a case that we can check. You cannot have 3 negatives and 1 positive. Let me go ahead and check if I can have 2 negatives and 1 positive. If I have -1, -1, 1 and 1. In that case, the first equation is satisfied. The second equation, is it satisfied? The -1 into 1 into 1 is equal to -1. Yes. Third one now, 1 into 1 into -1 is equal to -1. Yes. And 1 into -1 into -1 is equal to 1. Yes. This is an acceptable case. And for this acceptable case, can you see you are going to get 6 possible variations. Why 6 possible variations? Because essentially what we are doing is we are putting any 2 variables as -1, and that can be obtained in 4C2 ways. So, or 6 ways. We have 3 ways from here. We have 6 ways from here. Altogether, so far we have 9 ways. We have checked when all 4 of them were -1. We have checked when 3 of them were -1, did not work. We have checked when exactly two of them were -1. That worked. Let me check if exactly one of them was -1. Would this be acceptable? A into B into C is equal to D. See, it gets violated there itself. So this is not an acceptable case. Effectively, I now have a comprehensive list of cases. How many ordered sets would exist? Answer would be 9. Next, A, B, C, D are roots of the equation. X raised to power 4 minus x cube minus x square minus 1 is equal to 0. If fx is equal to this, fa plus fb plus fc plus fd is equal to. Okay, let's see. First thing I can see is within this expression, even here and here, looking at it only so far, can you see x cube is skipped over, x is skipped over? Among the first four terms of fx, if I take x square out common, I'm left with x raised to the power 4 minus x cube minus x square minus 1 minus x. This is what I'm left with. This is fx. Now for this term within bracket, I know the roots are ABCD. I know the roots are ABCD. So when I'm looking at FA, I'm effectively looking at a square into a raised to the power 4 minus a cube minus a square minus 1 minus x. And because a is a root of this expression, can I say this sorry, not minus x, minus a, this portion is going to be equal to 0. So fa for us is effectively equal to minus a. And this is not just true for fa. FB would be equal to minus b, FC would be equal to minus c, and FD would be equal to minus d. So when I'm looking at summation of FA, FB, FC, FD, effectively I'm asking for minus a, minus b, minus c, minus d, or negative version of a plus b plus c plus d. I'm looking at sum of roots for this equation. Sum of roots for this equation is 1. So the answer that we need for this question is minus 1. Okay, ABC printer prints wedding cards. A fixed number of cards is printed at a certain rate, and all cards above the fixed number are printed at a lower rate. Anish and Chetan and Bipin got their wedding cards printed at 9,000, 6,600 and 14,600 respectively. 1 minute. Anish and Chetan and Bipin got their cards printed at 9,000, 6,600 and 14,600. Okay. Bipin got 1,700 cards, and this was equal to the cards that Anish and Chetan together got printed. This was equal to, so if he had 1,700 cards, he had X cards, he had 1,700 minus X cards. Okay. Now, what is the absolute difference between the number of cards that Chetan and Anish got printed? Okay. Okay. Let's see what we can do with this. Here, can you see Bipin's cost is equivalent to some fixed charge plus some portion of variable pay. For Chetan, you also have fixed cost plus some portion of variable pay. For Anish, you have fixed cost plus some portion of variable pay. Now, if I look at this group separately, Anish and Chetan, they have paid the variable cost for 1,700 cards, and they have paid the fixed charges twice, 2 times the fixed cost plus the variable cost for 1,700. For Anish and Chetan, altogether totals up to 15,600. But for Vipin, fixed cost plus variable cost for 1,700 cards adds up to 14,600 only. So can I say the fixed charges here is equivalent to 1,000? Is equivalent to 1,000, which would mean, 1 minute. Getting rid of everything. If the fixed charges are uniquely identified as 1000, so I'm saying forget that fixed charges, forget those fixed charges. Effectively, fixed everybody has given 1000. For variable, Bipin has paid 13,600, Chetan has paid 5,600, and Anish has paid 8,000. 8,000 makes sense. Now, for 13,600 variable charge, he has gotten 1,700 cards. Or per card, can you see? This is variable charges. This is cards. So variable charges per card is equal to 8. Given it is the same location. Here also variable charge per card would be 8. Here also variable charge per card would be 8. 5,600 by 8 would be equal to 700. 8,000 by 8 would be equal to 1,000. So when they are finally asking me difference between the number of cards that Chetan and Anish got printed, the answer is 1,000 minus 300, or sorry, 1,000 minus 700, or the final answer is 300. Last question. If 17x plus 20y is equal to 2017 and x and y are positive integers, what is the maximum value of x plus y? 17x plus 20y is equal to 2017. Okay. The first possible case that you can potentially see is 1 and 100. This everyone can see. This everyone can see instantly, roughly. In which case, the sum turns out to be 101. But then our objective was not to find out a possible sum. Our objective was to maximize the sum. The next case that we would get here would have x increasing by 20 and y decreasing by 17. So next case would be 21 and 83. This has gone up by 20. This has gone down by 17. So overall, can you see the total sum will increase by 3? I will get 104. Okay. Which would mean if I go to the next case, my total sum increases. My total sum increases. So I will keep going down. I will keep going down. I will keep finding out new cases as long as they're positive integers, because the sum would be maximized then. So I keep increasing it. 41 and then 17 lower than this would be how much? 13 and 4, 66. Okay. Then 61, 17 lower than this is 49, 81, 17 lower than this is 32, 101, 17 lower than this is 15, 121, 17 lower than this is -2, and this would now become an unacceptable case because we wanted x and y to be positive integers. So this is the max case. 101 plus 15 is equal to 116. This has to be the answer. In case you are interested, you can also go ahead and see that the interim values would also have been increasing in steps of 3 only. The max value that we get is 116, which is the answer to this question. That will be all. Hopefully you learned something.